In this section, we're going to look at conjugates and division. In the previous example, you may have noticed that when you have two binomial factors and the only difference between them is the sign, you will have the middle terms drop out. And so there is this thing called a conjugate that is exactly that. The terms are exactly the same. Their signs on the second binomials are simply opposite. So the conjugate of a minus bi is a plus bi. Conjugates are used when dividing complex numbers. On this first exercise, we have 6i in the denominator, so we're going to multiply by negative 6i. Whatever we do to the denominator, we must also do to the numerator. 5 times negative 6i is equal to negative 30i. And 6i times negative 6i is negative 36i squared. If we simplify this, we get negative 30i in the numerator, and in the denominator, we get 36. We could reduce this by a 6. So negative 5i over 6. In this next example, we have something that's much more similar to the actual complex conjugates. So let's give this one a try. In the denominator, we have 3 minus 7i. So I'm going to multiply that by a conjugate. 3 plus 7i. Whatever I multiply in the denominator, I need to also multiply in the numerator. When I FOIL the denominator, I'll have 9 minus 49i squared. In the numerator, I'll have 12 plus 28i plus 15i plus 35i squared. This is equal to 12 plus 43i plus 35 times negative 1. So this will actually be a minus 35. In the denominator, we'll have 9 plus 49. This is getting closer to our actual exercise. The final answer we want of the form a plus bi. So now I have 12 minus 35. So that will give me 23, and that will be negative, plus 43i, all divided by 58. So my final answer is negative 23 plus 43i divided by 58. We can't really reduce this, so we will leave it just like that.